Today we will discuss about Hamiltonian cycle using backtracking. So here we can see that many graph problem is there. So in these topics we can discuss some points. These are what is Hamilton cycle, how it is solved using backtracking approach, using algorithm, how backtracking is useful for this problem. So at first you know the Hamilton cycle. So if graph is given, you have to start the process from any starting vertex and visit all the vertices and return back to starting vertex. So it's from say cycle and must be all connected to create a cycle. So like like as traveling salesman problem. So this is a NP hard problems also, means exponential time taking problem. So now for graph 5 there have create cycle or follow Hamilton cycle or not, let follow this. So here from this graph I have to start from vertex 1. Now you have to calculate how many possible cycle is create for this graph. So here last part you see that the starting vertex is 2 but the order is same as first part. So here we conclude that possible cycle of a graph depends on how they are arranged and same cycle cannot take in Hamilton cycle. So this is the path, that is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and 6 to 1. This is a path. Then another path is 1 to 2, 2 to 2 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 1, 3 to 1. So this is an path. So another path is 1 to 6, 6 to 2, then 2 to 5, then 5 to 4, then 4 to 3, then 3 to 1. This is another part. But when we come like that, 2 to 3, 3 to 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1, then 6 to 1, then 1 to 2. So this is as like as first part, so you can avoid this. So only the others part, that is that is create another order is but mainly order is different. It's always you can check the order mainly the different, because vertex starting vertex is one but the other vertices position always we can changing this part. So you can avoid this type of problem if we arise, so avoid for the Hamilton cycle problem. So next we can check the graph 1, that is there have create a cycle or follow Hamilton cycle or not. Let's follow this. So there have an graph, that is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 1 to 2, 2 to 3, 3 to 5 and 5 to 4, then 4 to 1. This is an part. And another is 1 to 2, 2 to 4, then 4 to 5, then 5 to 3 and 3 to 1. This is another part. So have in this graph more than one cycle is possible. So always you can check, that is in Hamilton problem more than one possible cycle is there or not. So next we can check the for graph 2 there have a create cycle or follow Hamilton cycle or not. Let's follow this. So here if you checking for cycle and starting vertex, if you check from 1, then if you go for 1 2 1 2 3, then 7, then 6, then 4, then you can go 1 but 5 is missing. So as like this like of graph, if you come from 5, then also 4 is missing. So so here vertex is 4 is also missing. So here in this graph all nodes are not connected and not create a cycle. It cannot create a cycle. So it's not follow the Hamilton cycle rules. So this is a problem. So next we check the graph 3, there have create a cycle or follow Hamilton cycle or not. So let's follow this. So here if you start from vertex 1, that is 1, so 1 to 2, 2 to 4, 4 to 3, then 3 to 6 or 3 to 5. You cannot get from 5 to 1 or 6 to 1, because here intermediate vertex 3 also is there. So via you can go from vertex 3. So this is a problem. So this problem cannot be arise in Hamilton, and it's not supported by Hamilton cycle rules. So it's also called as articulation point or articulation problem. This problem is also called. So avoid this type of graph. So now we can checking for graph 4, that we can create a cycle or follow the Hamilton cycle or not. Let's follow this. So here we can see also the, if we starting from vertex 1, that is 1 2 1 2 4 5, then we cannot go for 5 to 3 or 6 to 3 directly. So this is an pendant vertex. This also called 5 and 6 also called pendant vertex. So this type of problem also not supported by Hamilton's cycle rules or Hamilton cycle graph. So now we can applying the algorithm and backtracking approach for Hamilton cycle. So this is an algorithm part, and this is an graph that is supported by Hamilton cycle, and this is a matrix or adjacent matrix that will follow to which is connected or which is not connected. So 0 is represented as not connected and 1 is represented connected. So here we can take an array and we can check by array and fix the cycle point. So we can at first check from 0 0 position. So you already know the initial value is 0, that is shown in array, that is 0 0 0. Now for starting vertex, if you say vertex 1, then array will be starting from 1. So because we go for 1 1, then in matrix it will show 0 because there have no edges. So I can start from 1 to 2. So 1 1, it is showing that 1 1 position is 0. So 1 to 2 we can draw, that is 1. So there have an edge, so it is it's show in matrix as 1. So from this we can go for. So here we can see that is an algorithm. So in algorithm first part it is discussed, that is this algorithm follow backtracking or getting starting vertex. For the first part we can getting the starting vertex, this is the algorithm followed, and this second part also followed for getting next vertex, that is from after starting vertex the next vertex 2, from vertex 2 which is connected edge is there or not. So this is the calculation part. So here we can in this coding part you can taking the next value, and the mod is used for taking value as followed as checking the value. So as like as 0 1 2 3 4 5, next another next we can check for 0 1 2 3 4 5, as like as we can checking. So here we can take mod. So in this coding part, this code is for any edge is there or not, is connected or not in vertices, for the two vertices. For this purpose we can generate this type of code. So next the code is for checking for do not carry repeating value for any array. So if you check for once, then again one we cannot check. So for avoiding this type of part, we can coding like this way. So and the last part, that is the code is mainly checking for last position when it come in an array, then check it also connected to starting vertex and it should not be 0, then print out. So here you can check last position, that is 5 comes, and then it will from 5 to 1, if you from 5 to starting vertex 1 is connected or not, this part will be checking. For that purpose we can generate this type of code, and always not equal to 0 means it's not be not connected, it's not there, here always be connected. So this purpose we can generate this. So whole thing if you true, then it's written again and again this type of next vertices we can check. So because if you get go for 1 to 1, then is matrix it will show 0 because there have no edges. So I can go for 1 to 2, next we go for in third position is take 1, but is always there as like as 2 also there. So we take 3. So as like as we can generate all the figure, and then vertex 5 to vertex 1 also edge is there, so we get the cycle and print this answer. So if you draw the state space tree of whole process, then it's look like as 1 2 3 4 5. So this type of array we can cycle, if we will complete, then 5 to 1 always complete. So this creation is this create and cycle. So 0 we can start from 0 position, so then after 0 then 1 check by 1, then check by 2, then check by 3, then check by 4, then check by 5, then 5 is connected or not to 1, this also be checked, that is connected 5 to 1, that is 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 1. This cycle we can complete in this part. So as like as all other, this is an one possibility. So as like as many possibilities come,